Hey, Enid, do you have a second to help me? I cut my finger.
Oh, yeah, are you okay?
It seems like a lot of blood. I don't know how bad it is.
Okay, yeah, I'll grab
Okay,
the first aid
let's-
kit. Come on.
Okay.
Okay, there you go.
Are you sure it only needs a Band-Aid?
Yeah, it was a paper cut. You lost like 2 drops of blood.
I'm not really good with blood, especially my own. It just seemed like a lot.
Yeah, well, I've been working on a model of the human circulatory system, so I can tell you 2 drops is not a lot.
A model?
Yeah.
How much blood is in the human body?
Well, let's check it out. So there are actually 5 liters of blood in an average human body.
That's why you got these 5 liters of soda, was to illustrate how much that is.
Yeah, it was helping me with the model. So the heart takes about 1 minute to pump all 5 liters through the whole body.
That's a little harder to imagine. Can you explain the model to me? It's a lot of tubing.
Yes, it is a lot of tubing, but it starts right here with the heart, represented by these 2 pumps. One pump sends blood to the body, and the other pump sends blood to the lungs. These are the lungs. Yeah, and there are 2 basic types of blood vessels. The arteries carry oxygenated blood away from the heart, and the veins bring blood back.
Why are there so many different sizes?
Well, first, the arteries are smaller than the veins, but the farther you get from the heart, both types of vessels get smaller. So I've represented 2 basic sizes, large and small.
Cool. Well, according to our chart, the large arteries contain about 300 cubic centimeters. So the volume of a tube is the area of its cross-section times the length.
Yeah, and the area of the cross-section of this tubing is 0.31 square inches.
But we need square centimeters because our volume is in cubic centimeters.
Right, okay, no problem. So there are 6.45 square centimeters in a square inch. So we just have to multiply 0.31 square inches times 6.45 to get roughly 2 square centimeters.
So that means we need about 150 centimeters of tubing just for the large arteries.
Yeah, and the rest of the lengths of tubes can be calculated in the same way.
Cool. So we have over 140 feet of tubing in our model.
Yeah, and if we were to model the tiniest blood vessels, we would need over 60,000 miles of tubing.
Let's not do that.
No, we can't. So I've gotten extra lengths of tubing to represent those organs here.
That's very cool. Well, let's see if it works.
Yeah, well, I'll need your help.
Okay.
So both sides of the heart beat in unison. So we have to work these pumps together.
All right.
Cool? All right, ready? Go.
Oh, look at that, it's working. It's flowing. That's so cool.
So exciting.
That is amazing. It seems impossible that all 5 liters fit in just these little tubes.
Yeah, and of course the tubes are really long and that's the secret. But, all right, so give me your hand. I won't hurt you, don't worry. So we'll do 1, 2 little drops of water. That's how much blood came from your finger.
Okay,
Yeah. So
I
now
get
let's
it.
try something. Let's try adding a little food coloring to see the system in action.
Excellent.
Maybe you hit the syringe and I'll
Okay.
do the pump. Yeah.
Here we go.
You do it, and I'll pump at
All
the
right.
same time. Ready?
Ready?
And
Go. Whoa!
oh my gosh,
That's so cool.
this is crazy.
Pumpy pump. Look at that. We are fully
Pumping it.
circulated.
Yeah.
That's amazing.
Nice fresh blood.
Cool.
Crazy.
All right, this is cool. But Enid, please don't circulate my blood phobia around too much. Okay?
Yikes. All right, maybe you're feeling a
Circulate.
little lightheaded. Let's have you lie down.
I'm a little. All that
Okay.
pumping. I'm tired.